So I'm currently working for Uber, and I'm going to present one particular use case which caused us to come up with some kind of new abstraction, which might be useful for some of you. Who am I? I spent 7.5 years working for Amazon, and mostly doing backend and later AWS services, and probably most notable things, which is I was designer for clustered solution for messaging, which Amazon runs on, I think, still, and the same storage engine was used for SQS. SQS still runs on the same design, I think. And also I was tech lead for Amazon Simple Workflow service, which I think is very useful service, but certainly not very well known and certainly underused. And after, at Uber, I was less than a year, but we managed to design and practically implement a new messaging system. We call it Sharami, and we are planning to release it open source pretty soon, and keep looking for that. And I don't want to spend much time on it, but I think it's awesome. So you probably all know what Uber is, and Uber is about getting rides within minutes. And basic idea is that you open your app and you click where you want to go, and you don't want to wait too long for a car. Right? And we are trying to do everything for you to get that ride as soon as possible. And obviously, there are different mechanisms for that. Obviously, people are way about search pricing, and some people are happy or not happy about that. But even search pricing is not going to help if there are not enough drivers. So practically, especially when we have new marketplace, new city, when you try to start marketplace there are no drivers. So you can download the app, you go there, and there are like 5 drivers for the whole city. It's actually not going to help. You will wait a long time, not going to get it right. And the way we solve it, we practically provide guarantees for drivers, earning guarantees for drivers. Initially, practically, Uber pays for them just to be there and logged into the application waiting for the ride. And we guarantee that you get some money, even if there are not enough rides. And practically this way, we bootstrap the marketplace. And when there are enough drivers and riders, we practically don't need incentives anymore, because marketplace just start working naturally. And so driver incentives, this is a mechanism, and they are usually linked to a particular city or particularly even a part of the city. And obviously, they have some duration, and they link to type of vehicles and type of service. And obviously, you want to incentivize drivers with appropriate rating and just behavior which we want to incentivize. And just an example, it's not real incentive. I just came up with these numbers, but just to give you some idea what incentive could look like. It's just that we say, OK, we guarantee that you will get $40 an hour when you're online. But for that, you have to be some minimal number of hours online. You should be of UberX type vehicle. And you should get overall rating for the last 500 trips, no less than 4.5. And you need to have appropriate acceptance rate, which is how many trips you accept after you, like Uber proposes, like somebody asks for a trip, you can reject it or accept. So drivers which reject a lot of them, we don't want to incentivize that behavior. And when we started to look at that pipeline to process, so practically currently we use a schemaless database to process that. Basic idea is database with triggers. And you just save data there, you get triggered on changes, then you practically load stuff, state from database, you update it. And it creates new triggers, and you go back and forth. It works, but it certainly code is not, like even for simple use cases, your code is pretty complex, and also there are some race conditions, and it's not very efficient, because practically every transaction involves a lot of back and forth with databases, and it's kind of MySQL sharded database underneath. So the pipeline is pretty straightforward. We have so-called driver status change log. This is a log of events, like practically, for example, application, when a driver opens its application and logs in, we get an event, like driver online. When he turns off his phone or like logs out of application, we get event driver offline. Then he gets trip dispatched to him, we get appropriate event. When trip starts or he rejects the trip. Practically every event which happens, the only thing which log doesn't include is there is a separate log for GPS events and like events which come from phone, like low-level events like accelerometer and so on. But we technically could join that stream as well. And then right now, this driver status change log, there are different sources. It can be in Kafka, it can be in Schemaless, which provides Kafka-like APIs with partitions and offsets. And then we just key it by driver, and we have a incentive filter, and we have a bunch of microservices. For example, vehicle service, which you practically, because log contains only vehicle ID. So you can go to the service, look up the vehicle type, vehicle information, and see, okay, does this vehicle apply for the promotion, for the incentive? The same way for location, right? We just get GPS coordinates, we can map it to the city, and we can map it like, okay, does this incentive, like this event apply to the incentive, and so on. So there are a few other services which we actually consult before we can determine that this event is relevant. And then we just have a window, we accumulate all events during the incentive period. We also, as there is no guarantee for upstream source not having duplicates, so that's why we want to accumulate all events. And then when time comes, we also can practically emit event, do evaluation on every event because these rates are not extremely high really. And then we can save progress. But at the end, when we decide that, okay, we've got all data for given incentive, and we need custom trigger for that because this logic is actually kind of convoluted. Because it's more like a session, but it's pretty complicated session with different timeouts and based on different types of events we are getting and in which order. And then we evaluate the incentive, and we just practically generate some sort of record which contains all aggregates relevant to that. How much time the driver was online, how many trips he took, like ratings, and so on and so on. So there is nothing fancy about it, but it's certainly, you know, like business logic code. It's pretty ugly and long, but it actually works. And then we have database syncs, which saves the result in record to database, and there is separate service which actually takes care of actually paying or not paying and explaining why the payment happened or not to drivers. So this is pretty straightforward pipeline. Problem is that this pipeline is not what we want because there are thousands and thousands of incentives being active at any given time. So running 1,000 instances of this pipeline is just stupid, right? So we need a better way to actually calculate incentives. And the obvious way is actually perform some sort of join, right? It's actually not real join because we actually look up incentives from database. We obviously have cache of them. So it's more like a flat map, right? So practically we get an event. We look up from the location what incentives could apply. And then we just practically emit multiple records. So for every event, there are multiple, let's say there are 5 incentives in that region, we will emit 5 key incentive and status change log event records downstream. Then we apply the same incentives filter, and at the end, we practically, the difference is that we get, we have window, which is practically, it won't be per driver, it'll be per driver incentive pair, right, keyed by that. And then we just, evaluation happens the same way. So practically, we have single pipeline which can process all incentives for our drivers. So that practically was the implementation pipeline which initially came up with, and we implemented, and yes, it works, it produces results. And we thought we are done. Unfortunately, business, I always do that. Business has its own requirements, and for all sorts of reasons, incentives can be created retroactively. And it actually changes quite a lot. Like, as you know, when you do streaming, you can expect you always process current events. In our case, incentives, because they can be just advertised starting from Monday, but the actual registration could happen on Wednesday. And because they could be registered wrongly, we need to re-register them. So there is always a requirement that a pretty significant number of incentives are actually registered at the time when they actually started a long time ago. They could start like a few days ago. And that kind of broke the whole idea of using streaming engine, because we just, okay, what do we do? And most obvious kind of solution is, okay, let's do backfill pipeline. We have one pipeline which processes current events, and it just does what I just described, and it's all simple. And then we have pipeline which kind of catches up, right? We just, every time we have backfill, we go and create backfill pipeline and process. Obviously, if there are a lot of backfills, we technically can just accumulate them for some time, say, okay, we run this pipeline once every 5 hours or 6 hours, right? So we just will save all new incentive changes somewhere in database, and then this pipeline starts every 6 hours. It will pick up all those incentives and run the same logic I just described. So it sounds kind of reasonable. Problem is that what happens when this pipeline catches up? Because in a lot of cases, it's not just past incentives. It's incentive, for example, I mean, it's Wednesday, and incentive goes from Monday to Friday, and somebody registers on Tuesday. Okay, we come up with pipeline. By the by Wednesday, it got caught up, and then we are, okay, what do we do? And obviously, we have two options. One option is keep running multiple pipelines. By the end of the week, I will have like a dozen of them, or like more, and then maybe even for the same incentive with some changes, okay, we can make incentives immutable and just create new IDs, so it kind of will solve that problem. But at the same time, you still have this problem of running multiple pipelines, which is just ugly, and also it just uses too many resources, really. Other option is, okay, after we catch up, we just can hand over that incentive to the current pipeline. But after we started to think it through, it's actually ended up being extremely complicated, because first, Flink doesn't provide any mechanism for handing things over. We kind of make it one big pipeline with kind of sub-pipelines, but it actually didn't work out very well. Other option is that you kind of have external data source, so you practically save it there, and then you can reload in the, but then you need to ask initial source of original pipeline, start actually emitting records for that incentive as well, and change filters online, and then we want exactly once, because we're actually counting money there, right? Because single trip, double count at the lowest is actually pretty significant. If somebody is very upset, or at least a call to the customer service, which is expensive. So it's actually, we couldn't find good solution for that, because like just transferring these records from one pipeline to another ended up being very, very complicated. Probably more complicated than the whole pipeline. So reality is what we want. We want single pipeline, but we still want to process retroactive incentives. And reality, we come up with a solution, and this is our solution. It's not perfect, but I think it at least solves our problem. We come up with the idea of special source. We can call it on-demand source, or query source, like whatever, but think it is more like query source, but it's not a source really, because in Flink source has very specific meaning. It's the beginning of your pipeline, right? It has specific checkpoint, and it's the one which gets events from manager, or practically to start initiate the checkpoint. So this is not source, because it's more like flat map, right? It gets an event, and then it produces other records, but not asynchronously. But it is source because it actually reads from external data. But it's more like a source which has control. So practically think it is a like box which gets incentives input, data stream as input, and then based on that changes its behavior. So practically executes queries. Right, in our case, just scans the log. But it produces not just change events. It produces change events incentive pairs. Why? Because we want to kind of distinguish them right away, right? So it practically make this it's one stream which it outputs, but logically it's multiple streams. But you can always key them by incentive, and then this way you can make these streams more or less independent if you need to. And for optimization, logically, it executes every query independently. Every time it gets incentive, it starts emitting records for it. But obviously, it wouldn't be very efficient implementation if you need to replay days and days of data. So we use the same logic. We accumulate those, and then we periodically run the scan of the underlying stream. And obviously, watermark is useless in this case, right? Because you want to watermark practically per incentive, or at least per scan. But there is no notion there is only global watermark in Flink. So we practically just have to set it to the maximum value and forget about it. And obviously, we had to be careful about how these things checkpoints itself. This source has to make sure that it checkpoints all incentives which are in flight, and also offsets and all underlying scans which are going on right now. So practically, our pipeline looks like this. So we have incentive stream and source for the incentives. So every time new incentives is registered, we push it into the incentive stream. And then this on-demand source consumes that, and based on the practically incentives, logically at least starts pulling records which relate to that incentive from driver status change log. In real life, it scans the whole log based on the time window of the incentive, but then it can perform its own, and again, it's implementation detail. It can perform some filtering internally. Technically, it could emit all records and then do filtering out as a next step. So there is no requirement that it performs filtering internally. We implemented some basic filtering by region internally, just to not emit too many records out of the source. And then the rest of the pipeline is the same, right? We key by driver, we have incentive filter, and then we have driver incentive window. And then and we have practically the same custom trigger, and then there is a time to fire. It fires and saves the results to the database, and can do it periodically on every record, so we have progress of incentive or just at the end. That is practically the gist of it, is that having this kind of abstraction of the data source, so if you think data stream in this case, not as just data stream of current events or events in some order, or even like event order with event time, or it's like practically union of multiple streams, one per logical query, you can actually have a single pipeline which processes multiple of those queries at the same time. It is very unnatural for stream processing, but at the same time, I found that it's maybe useful abstraction for some cases. So that's practically it. Then I thought a little bit, and I'm like, OK, but it's ugly, right? And it's very specific to our use case. Can we have something which is solves this in generic way? Because it looks like it's a very common problem. For example, I can imagine we have SQL statement, right? We have SQL now, or will have SQL, right? And then you have select clause on where something, and this where can be region, for example, now say city. And then you want to change city, right? Query is fixed, so your pipeline will always look the same. You will change city. Question is, how do you execute these queries in parallel? Can I execute 100 queries with different cities in my pipeline without instantiating 100 pipelines? And should I write every time new data source or whatever? And this is absolutely thinking about it. I just remembered our initial pipeline for a single incentive. So this pipeline is very simple, right? It's extremely simple. It's clear. There is no magic. It's just, OK, we take data, we filter it for single incentive, we do aggregation per driver, and we emit results, and it's very clear. All other things I've done, they actually were just walkarounds for practically limitations of technology. And limitation is that I don't want to run 10,000 pipelines, right? So thinking about it, I come up with absolutely crazy strawman idea is that why we don't have something like template? And again, name template is absolutely strawman, and you can come up with any other idea. But basic idea is that you have pipeline which can be parameterized. And physically, it runs as a single pipeline, but logically, it's practically instances of pipelines. And each of these instances practically just has those parameters as first key of every message and every value and so on. So this way, you can logically practically go and instantiate million of those pipelines, and at the same time, they just run on the same physical set of slots and practically the same operators, right? So let me read what I wrote there because I forgot it about already. But yeah, so basic idea is we set parameters. In our case, it will be just incentive, right? And then when you will need to have some special operator or some special way. Maybe from within the other, like if we have pipeline which receives incentive, maybe we should be able to instantiate the sub-pipeline kind of instance of that, or maybe even through CLI, I don't know. But there is a way to instantiate that and specifying parameters. As soon as you specify parameters, the underlying system will just treat it as just the way to separate keys, the same way as we did it manually in our previous pipeline implementation. And also, it kind of assumes that underlying source, it can run multiple times, but technically I can see a situation when we can write special kind of sources which are optimized to take care of, like, for example, coalescing multiple requests together, right, and running it once, for example. If it's, for example, SQL, which actually runs SQL query against database, it can be every time you get new requests, you actually can run new SQL query against database. But if it's something like your source is more like Kafka, you don't want to scan like huge backlog on every request. You probably can coalesce them and then run it periodically every hour or so. So yes, you need special kind of sources if you want to take advantage of that. But all other parts of the pipeline can actually be just shared. Okay, that is probably the first part of the talk. And yeah, here's how probably this pipeline would look like, right? So it will be more like the same pipeline as my original pipeline. The difference is that it will be kind of templated on incentive, and then I will just instantiate multiple of them. So that is kind of part of my talk, and I just decided to have this opportunity just to talk about some other feature requests, which I don't think were mentioned during recent sessions. We obviously asked Flink guys for all sorts of features, but most of them are obvious, right? We want a dynamic repartitioning, we want scaling, we want all sorts of big state support and so on. But those are we are talked about. I think these are a few which probably weren't very well, kind of not. At least I didn't hear people talk about them. First, I think there is a use case for per message error handling. I'm coming from messaging system background, and there it's very important to support poison pills, right? When you get a message which cannot process, you don't want to block your queue. You want to try it a few times and then put it in dead letter queue. So, for example, dead letter queue for messaging systems is very important because you want to make sure that you always make progress, but don't lose messages. You cannot just drop it on the floor. Flink, the way it is right now, it kind of drops the message on the floor or stops your pipeline. There is no kind of clear way to try some message a few times, mark it as something unprocessable, and just put it somewhere, at least clear, like out of the box. Maybe you can write code for that, but we don't even have side outputs yet. But I know that people are working on them. But the idea is, could you have some sort of register, I don't know, queue or processor or and for the whole pipeline, but ideally even for part of the pipeline, I want some sort of scopes, right? So ideally I want to say this part of the pipeline protected by this handler, and then every message which cannot be processed for whatever reason goes there, and maybe there is some retry policy, but point is that I want to be able to actually handle individual poison pill messages, not the whole pipeline going broke. And sometimes, like in any real systems, you always get those corrupted messages which are not processed, and you don't want to stop your pipeline. Other part is runtime visibility. So we have this nice new feature of practically querying state out of the running operator. But what I really want, I want to be able to practically go to my browser, find any operator in my graph, open it, and see what's inside of that window. Right? Why I cannot have particular window for particular key? Because all data is there and just should be exposed. I practically want to intercept everything my pipeline is right now has in memory, and like all its state of the trigger, practically of every component. Because right now it's a black box. I deploy it, it runs, I see some counters not incrementing, and I have no clue why it's there, what's going on. It's usually a bug in my code, but finding that in production is extremely hard. So I want to be able to practically go and touch every part of pipeline, and over here, over every stream, like any edge of the graph, and also every vertex. So that is probably another important feature for troubleshooting. Triggering windows, I see it coming up on the list all the time, but I want to be able to say, okay, start triggering for this key on empty window, and I want to do that every 15 minutes, independently if there is data there or not. Right now, it's extremely hard to do. The only way to do that is to have global window, which kind of defeats the purpose of having all these nice tumbling windows and so on. That is something which I had to implement a few times using global windows, which wasn't very, I think, the best solution. Pipeline graph rewriting. We try to build platform for other people from our company deploy pipelines. But what we found is that we have some framework code. We want to make sure that when they deploy their pipeline, we can actually add some pieces of our framework code to their pipelines. Most basic one, for example, we want sources. We don't want them hard-code sources. We want to just them provide name of the source, and then based on the name and some external configuration, or even external service lookup, come up. For example, they provide source, and we say, oh, it's a Kafka, but this Kafka topic lives. We need to look. This Kafka topic lives in. For example, in this cluster on this IP address, on this zookeeper, right? So it's actually service lookup. I don't want them hard code any of that in their pipeline, right? So, or we want to make sure that we can put some sort of interceptor or login or whatever component. So ideally, what we want is that when they submit their pipeline, we get the graph of their pipeline, and then we can modify it any way we want as a framework of, like owners of the platform, and then actually make sure that what is deployed is actually a mix of their code plus our code. So like everyone who knows what interceptors are and how like aspect-J works, so this is actually what would be probably on the like pipeline level. This last one is kind of funny, is that for the messaging system, which we wrote, we wanted to actually integrate that. And the operation which takes offsets is a separate operation. It's not like in Kafka when you get offset with every message. You practically can go to the system and say, give me current offset. And it will give you current offset. But at the same time, you are consuming. And there is a race condition there. So all we want is being able to get callback before checkpointing of source starts. Practically, we want to say, sure, OK, call this callback after we execute and checkpoint this kind of callback. Then you can just start checkpointing sources. That is kind of just one special feature which we requested. It's not that hard to implement, but it's something which could be useful for other sources. Because otherwise, there is inherent race condition. Then you have multiple source tasks for a source, and they just checkpoint independently without any ordering. I probably was faster than necessary, but this is practically it. Any questions? What's the secret? I don't know it. Okay.
Hi. I actually have answers instead of questions, which is that what you've done with kind of having a function that accepts the description of a stream and then emits it is a new feature in Beam called splittable do-fun that's under development. And also there's a proposal for Beam to have pipeline templates. So I think you might find it interesting at least to read over those proposals and see.
Hello.
Thanks.
I was wondering if you, why didn't you start a new job per incentive instead of starting, I mean, you're multiplexing the input stream into like one stream per incentive. Why aren't you starting a new Flink job per incentive instead?
So let's say we have 1,500 incentives. Do we want 1,500 Flink jobs?
Maybe.
At least the way Flink is right now, with only a single, for example, slot type, which is practically, it would be impractical, right? We probably will use like 100x more resources than necessary.
Okay.
That is probably the main idea. Also, managing that is kind of insane, right? Because like all failure modes and everything, compare a single pipeline with like 3 tasks versus like 1,500 of those. It's just the complexity.
But are you always multiplexing the events going into the event stream, or are you, when you catch up, are you like appending an array of the incentives you currently have active so that you don't multiplex all the events all the time?
So the thing is that when we have this kind of multiplexing source, it kind of happens naturally, right? It just plays. When it catches up, it just starts emitting only current messages, right? There is no, you don't need multiple scans, right? It can be smart because it's very easy to do handoff because the only thing you need to make sure that you don't lose message there, right? When you have separate pipelines and you want to make sure that this pipeline hands over data to this one, then it becomes very hard, right? It's much easier to just have source which catches up and make sure that it just didn't lose messages. Just very minor race condition there.
So I was wondering if one would attempt to implement such a template library on top of the current streaming API in Flink for generic templates. Are there some inherent limitations in the semantics of the stream processing framework itself that prohibit this? For example, you say that watermark should be kind of keyed or kind of dominated by the template parameter. So can this be realized on top of the current state of the art, let's say Flink 1-on-1, or are there some framework modifications that are required to do this?
To tell the truth, I didn't look very carefully in what watermark is right now. My guess is just a special type of message. So keying that on something probably, I think independently from this completely, having multiple watermarks is a good idea. For example, I want a watermark when I've got 90% of data, I want a watermark when I've got 95, and I want when I've got 99. Even like on a single stream, right? Right now you cannot do that. So because watermark is just saying you've got that much, right? And why you need only one, it's just, I think, limitation of current implementation. So having ability to key on something and have watermark per key could be also useful independently from this. So for me, watermark is, and again, but the only problem the way Flink does is like watermark is just kind of has its own type, right? Because right now stream has very specific type. You always can model that doing unions like this, practically like joins and like ugly tuples. But it's mostly about, I think, the way we deal with stream typing of streams. Watermarks just kind of untyped control events. Maybe we need other control events. I don't know, because I can imagine the control events being a separate abstraction in Flink, which I still don't grasp very well, but I think there is some room there.
Can you have any special source for backfilled messages? Can you go back in time for, I don't know, a few months to compute incentives?
We can, yes, because our source actually contains data almost for the whole existence
Kafka?
of the company. No, it's not Kafka.
Something's open source?
No, it's schemaless. It's our database. It's practically a database which provides trigger semantic. It's actually, there is an article on that on our blog. I don't think it's open sourced yet. But basic idea is just sharded SQL database, and every time you do update, we do insert, and actually this insert is actually can be treated as a message with offset. So when you read that, you get exactly the same like Kafka semantic. So schemaless source is almost the same as Kafka source. Simpler, because Kafka source is very weird because it uses this, I think it tries to pass piece of data like from one part to another, and like most of the complexity there, not because of the offsets, it's because of just the way it passes data around. Yeah.
Thanks.
Hello. Can you please just clarify on the business event side, you had like an incentive created event or something like that. And for the repopulation, do I understand it correctly that you had no such thing as recreated as a business event? Or sorry, created retroactively?
So I certainly simplified a lot, right, that, for the purpose of this presentation. Is usually what will happen is that you will update the database, and every time you update that, right, it will kind of generate new version of that, then it will create the event, something like that.
But
yeah.
the necessity to sort of replay historical events was because of this notion of a retroactive thing being created?
So practically every time you create incentive, and it starts, and there is start and end date of every incentive. If start date is before current, you have to replay.
I see. Okay, thank you.
questions? Okay.
Okay, thank you.